As we continue to extend our understanding of the properties of exponents, we're going to talk about division properties of exponents and the fact that when we have like bases that are being divided, what we do with those exponents. And to divide powers with the same base, we go ahead and we subtract those exponents. And to expand on that understanding, let's take, for example, before we even start doing our notes, if we have x to the fourth divided by x to the fourth, well, we've learned in the past that when we have something divided by itself, it is 1. So we know that that is 1. And if we were to use the division property of exponents, well, we would turn around and say we subtract like bases. But before we use that property, let's see, we know that that's 1. How about if we take x to the third divided by x to the seventh? And if we write that out in expanded form, we would have x times x times x over, of course, this. Right? We would have x times itself 3 times in the numerator and x times itself 7 times in the denominator. And as we go to simplify that, we know that x divided by x becomes 1, and we're able to do some simplification there. And it turns out that we get, this is going to simplify down to 1 over x to the fourth, which we actually know is also considered x minus 4, and those two things are similar statements, equivalent statements. Well, we're going to learn here that when we do like bases, we subtract our exponents. So we could have completed this problem using the division property, and it would be x to the third over x to the 7. So we subtract our exponents, so it would be x to the third minus 7, which turns out to be x to the negative fourth. So there you have it, doing the expansion method, looking at some of the things and how they simplify out. We would have x to the negative fourth, and of course we know that we can go full circle and have that as 1 over x to the fourth. So again, just sort of discussing the exponent rules prior to even getting started. Some of the things that we may know. So as we go forward and we do some examples, we have that division property. So when we have like bases, we're going to subtract our exponents. So what is a simplified form of each one of these expressions? Starting off difficult, no more reason than because we have a fraction, but we do have like exponent or like bases. So we can go ahead and say we have y 3/4 minus 1/2, because we're going to subtract our exponents. And that would become y 3/4 minus 2 over 4, because we have to have common denominators when we are adding or subtracting fractions. And then that becomes y to the 1/4. So that simplifies down to y to the 1/4. Looking at b here, again, we have like bases. It's d. And we're going to subtract, since we are dividing like bases, we're going to subtract our exponents. So we would have d to the 7/2 minus 3. Again, we have to have, in order to add or subtract fractions, we have to have a common denominator. So that becomes d, sorry, not equal to, d to the 7/2 minus 6/2, or d to the 1/2, simplified down. And so again, when we have division property, when we are dividing like bases, we will go ahead and subtract those exponents. Okay, well, as we get into another example here, we have two variables, and we know that those two things are being multiplied by each other, right? So we can go ahead and use some of our, let's just go ahead and separate those to where they're a little bit easier to see. So we would have k to the 6th divided by k times j to the 2nd divided by, sorry, I'm really bad about that, j to the 2nd divided by j to the 5th, which becomes k to the 6 minus 1, right, because that's a 1, times j to the 2nd minus 5. So we have k to the 5th times j to the negative 3rd. Now we know that we can reorder that. I'm sorry, not reorder that, rewrite that in the positive exponent, so we would find the reciprocal. So we would end up with k to the 5th over j to the 3rd when we go ahead and we have written that in its simplified form with positive exponents. Okay, goodness gracious. Let's see here. We do have some like stuff we can, we have like bases there that we're going to go ahead and multiply. All right, so we end up with, if we tried to rewrite that, just to make it a little bit more clear, we have a to the negative 3rd over a to the 5th times b to the 7th over b to the 2nd. And I end up then with a to the negative 3rd minus 5 times b to the 7th minus 2, which gives me a to the negative 8 times b to the 5th. When I rewrite that with my positive exponents, remember I'm looking for my reciprocal here to give me a positive 8 exponent, and that becomes b to the 5th divided by or over a to the 8th. Okay. Simplifying these expressions with like bases. And let's see here, we know we have a bunch of multiplication going on here, so we can rewrite it. I rewrite it because I feel it makes it a little bit more easier. So I have x to the 4th divided by x to the 4th times y to the negative 1 divided by y to the negative 5 times z to the 8th over z, which is z to the 1st. I'm going to go ahead and write all these works out. So I know that I have x to the 4 minus 4 times y negative 1 minus a negative 5 times z to the 8th minus 1. And this becomes x to the 0, which is 1. And this becomes y to the 1 minus a negative becomes y plus 5. And that would be y to the 4th times z to the 7th. And therefore we have 1y to the 4th times z to the 7th, or just y to the 4th, z to the 7th. And there you have it. We've done some algebraic expressions using the division properties of exponents. Okay, so population density. So we're going to start talking about scientific notation again and using some of our properties. So population density describes the number of people per unit area. And during 1 year, the population of Angola was 1.21 times 10 to the 7th people. And then the area of Angola was 4.81 times 10 to the 5th miles squared. And what was the population density of Angola that year? Well, it just said that my density, right? My density is going to be equal to the population per area. Okay, so when I rewrite this, I'm going to have my population, which we said was 1.21 times 10 to the 7th, divided by my area, which was 4.81 times 10 to the 5th. I can do some simplifying there, but let's just group the things that we know go together. I have 1.21 and 4.81 times 10 to the 7th over 10 to the 5th. So as we simplify this, we end up with 1.21 over 4.81 times 10 to the 7 minus 5, which is going to end up giving me 0.252 times 10 to the second. To get this in scientific form, remember we need to, scientific notation, we need to move our decimal place. So that is going to be subtracting it by 1, or if we go ahead and just get rid of scientific notation all the way, because we can here, that would end up becoming, let me see here, 2 decimal places, so it would be 25.2, and that is in context people per mile squared. Okay, so there's my answer, 25.2. And then it is asking me, this next one is, we're working with density again, population density, and that is again going to be my population divided by my area, and that is going to be equal to my population, 7.33 times 10 to the 6 people, over, or divided by, 4.33 times 10 to the 4th area. All right, so we end up with 7.33 divided by 4.33 times 10 to the 6 minus 4. That's going to give us 1.69 times 10 to the second, which is going to be equal to 169 people. 169 people per mile, per square mile. Okay, so there we go, in context, being able to use that scientific notation using the division property of exponents, and we're able to come up with these examples. Now, raising a quotient to a power. Okay, so we had worked with multiplication, a power to a power. Well, we're going to have now a quotient to a power, which is going to be the same principles, and in effect, should be no more difficult. So we do know that, what do we need to review here? We know that this exponent goes to this. We know that the 5 is an exponent of 1, and we know that the 3 applies to everything within our parentheses. So, raising a quotient to a power, what is the simplified form of this quotient? Well, I know that it should be equal to z to the 2/3 raised to the 3rd power over 5 to the 1st raised to the 3rd power. And now when we are in a position where we can multiply we are multiplying our exponents. So we have z is going to be to the 2/3 raised to the 3rd, so it's going to be times 3 over 5 to the 1st times 3. Simplifying, we get z to the 2nd over 125. Remember, these cancel out when we simplified our expression. So there you go, simplifying with a quotient. Looking here on this next example, we have, of course, there's nothing to do inside the parentheses, right? There's nothing that we can do between the 4 and the x to the 3rd power, but remember that is 4 to the 1st over x to the 3rd, and this squared goes to everything inside, so that can be rewritten as 4 to the 1st squared over x to the 3rd squared. Simplifying that out, we know that this would be 4 squared over x to the 3rd times 2, which is going to give me 16 over x to the 6th. And there we have it, simplified expression. So describe 2 different ways to simplify this expression with this quotient. Now, we could do it this way. The 2 ways that we just did, we can go ahead and distribute first. So we would have a to the 3/4 over a to the 5th raised to the 4th power, and that would equal a to the 3/4 times 4 over a to the 5th times 4. because this goes to both all of the information on the inside. Now, in doing so, we simplified this, and that would give us a to the third over a to the 20th. And then that would give us, combining like terms, now we are division with the same base, we would have a to the third minus 20, which is going to be a to the negative 17, which is also 1 over a to the 17th. That's one way to do it. Again, I went ahead and shared out my exponent, doing the multiplication property, and then did my multiplication. I had a to the 3/4 times 4, which gave me a to the third, over a to the 5th times 4, which gave me a to the 20th. Simplified those like bases, simplified this negative exponent, and came up with this answer. But if I were to do it a different way, what I could do is turn around and say, well, I have like bases within the parentheses, so I can actually do what's in the parentheses first, which we could argue is my order of operations. So I would have a to the 3/4 over a to the 5th times 4. So I would have a to the 3/4 minus 5 over 1 to the 4th. Let's see, simplifying, if I'm going to subtract these fractions, I need to have a common denominator. So I'm going to have a to the 3/4 minus 20 over 4 raised to the 4th power. That is going to give me a to the negative 17 over 4 raised to the 4th power, which is the same thing as a to the negative 17, 4 times 4 over 1, which is going to give me a to the negative 17, which we rewrite with a positive exponent as a to the positive 17. So it looks like, depending on which way I do it, I would have come up with the same answer. As long as you follow your properties, you are going to come out with the correct answer. All right, simplifying an exponential expression. What is the simplified form? Well, let's see. We have 2x to the 6th over y to the 4th to the negative 3rd. There's nothing inside those parentheses that I can simplify. So let's just go ahead and we have 2x to the 6th to the negative 3rd over y to the 4th raised to the negative 3rd. I need to remember that that is 2 to the 1st, and that my exponents go to everything within those parentheses. So that becomes 2 to the 1st raised to the negative 3rd times x to the 6th raised to the negative 3rd over y to the 4th raised to the negative 3rd. And we know we have a lot of stuff going on here. That would be 2 to the 1 times negative 3. This would be x to the 6 times negative 3. All of that over y to the 4 times negative 3, which is going to give me negative, 2 to the negative 3rd, x to the negative 18 over y to the negative 12th. And we do our inverse operations, or not really our inverse operations, but in order to make those exponents positive, we need to do the reciprocal. So in doing the reciprocal, we end up with y to the 12th over 2 to the 3rd x to the 18th, which is y to the 12th over 8x to the 18th. A lot of steps there, but I was trying to make sure you saw the flow and the thinking that was going on. So walk back through it for a second if you need to see all the different operations. And then this one, I'm going to bring over here to where I have a little bit more room. And I am going to have a to the negative second over 5b to the negative second. Remembering all my exponents there, so I have a to the first power times negative 2 over 5 to the first power times negative 2, and b to the first power times negative 2. And let's see, how do we simplify this? Then that would become a to the negative second over 5 to the negative second times b to the negative second. And in doing my reverse, my reciprocal here, this should become, I find the reciprocal to get my positive exponents, so that should become 5 squared b squared over a squared. Finding the reciprocal creates the positive exponents, and that can be simplified down to 25 b squared over a squared. Properties, moving these variables around, extending our exponent rules, all of these things are tied together and become much more, they become easier with practice. So as we talk about the stuff that we have done, we continue on with our quotient rule, which, okay, so the quotient rule is when we divide powers with the same base, subtract the exponents and keep the base the same. So looking at an example, or the rule, right, we would have a to the b over a to the c would be equal to a to the b minus c, because we're going to subtract their exponents. Or if we had x to the 9th divided by x to the 3rd, that would be x to the 9 minus 3, or x to the 6th, as an example. So there you have it. We have gone over the quotient rule. And again, these all should start to, we're using these all interchangeably, in a sense that you may have more than one rule going on in a given expression. So you need to be aware of all the different examples and possibilities. The more you know, the easier the math will become.